what is e to the I theta minus I theta over 2 sigma y? Well, there are two ways of doing this. Actually, there's probably more than two ways of doing this. Two ways to do it. Diagonalize. So you find u, so u sigma y u dagger is equal to a diagonal. Exponentiate d. So that gives you e to the minus I theta d over 2. And you can do this just by taking each of the diagonal elements of d and raising it and exponentiating it to get e to the minus I theta d sub I over 2. And then undiagonalize. Reverse u. So you now have u dagger e to the minus I theta d over 2 u. But I want to do it the other way just to show you how the other way works. Okay. Yeah, good. E to the I theta over 2 sigma y is equal to I. What we're going to do is just write this out in terms of a Taylor series. Minus theta over 2 squared, sigma y I plus I squared theta over 2 squared sigma y squared. And I think we need a 1 over 2 factorial plus 1 over 3 factorial times I times theta over 3 theta over 2 cubed sigma y cubed plus dot dot dot. So what we want to do is I want to say the even terms are I minus 1 over 2 theta over 2 squared. Sigma y squared is I because you take any of the Pauli matrices and you square them and you get I, plus 1 over 4 factorial theta over 2 to the 4th times I, dot, dot, dot. And the R terms, well, all the, sigma y is sigma y cubed. So this is sigma y okay, so this is minus I theta over 2 plus I cubed over 3 factorial theta over 2 cubed, etc. And this is just cosine of theta over 2, and this is minus I sine of theta over 2. So this is cosine theta over 2 times I minus I sine theta over 2 times sigma y, which is equal to cosine theta over 2 minus sine theta over 2 sine theta over 2 cosine theta over 2. Gosh. Now it seems to me I've gotten one of the assuming I didn't get this sign wrong, but you can see this is just a rotation of angle theta over 2 in the xz plane. So this is how you get rotations of theta around the z-axis, the y-axis, and the x-axis.